Bear, it behaves like one. In winter, when bears hibernate, Ursa Major is down low, close to the horizon. In springtime, when hungry bears wake up, Ursa Major prowls high and away from the horizon. This predictability suggested that the stars could be used to guide us. As we searched for other patterns, we projected our dreams and nightmares on the canopy of heaven. We filled the sky with stories. Kings and queens, monsters and heroes parade through the night. These star pictures, called constellations, transform the sky into a book of legends and folklore that anyone, from shepherd to shaman, could read. The stars do not dwell alone. Two brighter lights dominate the heavens. One is the moon, which treks across the sky just like the stars, but unlike the stars, it appears each night or day in a different place in the sky. It also changes its shape. Sailors and fishermen noticed that tides followed the moon. People in every culture counted full moons to measure time. Even our word month comes from moon. The brightest light in the sky is the sun. Many ancient peoples worshipped it. Their lives depended on it. Its changing path across the sky defines the seasons. When to plant, when to harvest, when to hunt for migrating animals. Because the sun and moon move with apparent purpose and clearly do influence events on Earth, people wondered, are there other moving celestial lights that affect us as well? Skywatchers noticed that some of the brighter stars move out of sync with the other stars. They called these 5 wandering lights planets. The Greeks explained the motion of the stars by imagining that they were lights fixed to a gigantic sphere that turned about Earth. But they were baffled by the planets, which move at varying speeds, and sometimes even abruptly change course, as if they were deliberately moved by the gods. Skywatchers observed that these wandering planets travel through a very narrow band of the sky called the ecliptic, and it passes through a series of constellations known as the zodiac. Around 2000 BC, astronomers in ancient Mesopotamia divided the zodiac into 12 constellations or signs. We've all heard of Scorpio, Sagittarius, Taurus, and the like. Ancient astronomers thought of the zodiac as a stage on which the sun, moon, and planets performed, acting out a story that we could perhaps understand. Ancient kings and generals, grasping for hints of their future, paid soothsayers to predict and interpret the motions of the planets. These astrologers helped lay the foundation of our oldest science, astronomy. They tried to make sense of the strange dance of the planets. They measured positions, kept careful records, and stretched their imaginations to explain what they saw. The first theory that seemed to work dates back to the 2nd century. Alexandria in Egypt was the center of education in the ancient world. Scholars from all over the Roman Empire came here to study. Astronomers in ancient Alexandria didn't have telescopes. They used an armillary sphere, a device constructed of metal rings to track the stars and planets. Claudius Ptolemy was the greatest geographer of his time. Columbus would one day use Ptolemy's maps to plan his daring voyage across the Atlantic. But Ptolemy also wanted to chart the heavens. Using geometry, he devised a system that seemed to account for the wanderings of 7 celestial lights. moons: Mercury, Venus, Mars, Jupiter, and Saturn. Like other astronomers before him, Ptolemy assumes that Earth is the center of the universe, fixed and motionless, and that the planets are attached to rotating transparent spheres. To account for the more subtle motions, Ptolemy believed that each planet also moves on its own smaller circle, or epicycle. Spheres and circles were considered divine forms by the ancient Greeks. Any description of the universe required the divine planets to move along perfectly circular paths. Ptolemy's system of crystal spheres, whirling within a shell of stars, worked well enough to predict the motions of the planets. For 1,500 years, Ptolemy's view of the universe stood largely unchallenged. In the 17th century, a courageous thinker drew a very different picture of the cosmos. He was Galileo Galilei of Italy, the first modern scientist. Galileo's revolutionary discoveries were made with a device designed to bring distant objects closer to home. In the winter of 1609, he mounted 2 lenses in a paper tube. It only had the magnifying power of a good pair of modern binoculars. Still, when Galileo pointed his simple telescope at the night sky, he saw things no one had ever imagined, things that challenged many long-held beliefs about our place in the universe. When he looked at Jupiter, Galileo discovered it is circled by 4 moons that have never been seen before. This means Earth is not the only center of motion in the universe. When he observed our own moon, he saw it is not a perfect sphere. It actually has mountains and valleys. So Earth is not the only physical world. When he observed Venus, Galileo discovered the planet goes through phases, from crescent to nearly full, and back again, phases that are impossible in Ptolemy's Earth-centered universe. Galileo's observations convinced him 15 centuries of established thought must be wrong. Half a century earlier, a Polish astronomer, Nicholas Copernicus, had already theorized that the sun, not Earth, is the center of the universe. Now, Galileo had evidence that proved it. Placing the sun at the center accounts for the phases of Venus, explains the motions of the planets, and proves that Earth, too, is a planet orbiting the sun. Galileo also discovered that the Milky Way is made up of countless dim stars. To be so dim, they must be farther than stars visible to the naked eye. Perhaps space is not bounded by a crystal sphere after all, but filled with stars. If this were true, Ptolemy's crystal sphere would be shattered, and the universe would be truly immense. In 1781, William Herschel in England discovered the planet Uranus, doubling the size of the known solar system. Later discoveries would increase it further. But Herschel was after even bigger game. He wanted to map the universe. After 30 years of painstaking observation, he concluded that the universe is shaped like a wheel, with our sun at the center. He called this system of stars the galaxy. At the beginning of the 20th century, the American astronomer Harlow Shapley discovered that the galaxy is even bigger. It contains billions of stars, and our sun is nowhere near the center, but in the suburbs of this celestial city. For nearly 2 decades, most astronomers believed that the Milky Way galaxy was the whole universe, all of it. In the 1920s, astronomer Edwin Hubble challenged that idea. A 100-inch telescope at Mount Wilson Observatory overlooking Los Angeles was the largest of its time. With this powerful telescope, Hubble observed mysterious objects known as spiral nebulae. He trained it on the best known of these, the Great Nebula in Andromeda. Looking through an eyepiece, earlier astronomers had sketched the nebula, but they could see little more than a foggy patch of light, with a hint of structure. Hubble applied photography and transformed his telescope into a giant camera. His photographic plates soaked up light gathered by the telescope over the course of several hours. What they revealed was amazing. Millions of stars that are too faint for the eye to see. Careful measurements of these stars allowed Hubble to calculate Andromeda's distance. He determined it isn't in our galaxy at all, but lies far beyond the stars of the Milky Way. The universe must be huge. Hubble's photographs proved Andromeda is another galaxy, just like the Milky Way. And the universe is filled with galaxies. Once thought to contain all of creation, our Milky Way is merely one of billions of galaxies. By measuring the motion of the most distant galaxies, Hubble made an even more startling discovery. All the galaxies are moving away from us and away from each other. The universe is expanding. Modern astronomers have discovered a universe so vast that light from its most distant parts takes billions of years to reach us. We've learned that galaxies are not scattered randomly, but congregate in clusters surrounding bubbles of emptiness. And radio telescopes have revealed that the entire universe glows with energy. What is this mysterious cosmic light that shines from every direction? Why does the universe have such a strange architecture? And why is it expanding?
He's happy.
Like Ptolemy nearly 2,000 years ago, modern scientists use the language of mathematics to tell stories about the universe. They test theories by constructing virtual universes using computers that can do trillions of calculations every second. The story scientists tell today is as strange as any ancient myth. Astronomers think that around 14 billion years ago, everything, all matter and energy, time and space, was compressed into a point smaller than an atomic nucleus. We have no idea what the universe was like in this state or what existed before it. But something triggered the biggest explosion of all time. It was not an explosion of matter into space, but an explosion of space itself. As that cosmic fireball expanded, it cooled. Energy transformed into matter. In time, the relentless force of gravity herded clouds of matter into stars, and galaxies, and clusters of galaxies. Today, the universe is still expanding from that ancient Big Bang that we think started it all. The light shining from all directions is the fading afterglow of that primordial explosion, a snapshot of the universe just after it was created. Computer simulations of the early universe show how clusters of galaxies might have condensed from gas clouds. These simulations show the same cobweb-like structures we now observe. That makes us think that our theories about the Big Bang and cosmic evolution provide a good explanation. But, like many astronomers before us, we are struggling to explain new observations that don't seem to fit our theories. For instance, the universe seems to be filled with invisible material called dark matter. Without it, the universe would have expanded too quickly and galaxies would not have formed. We know dark matter exists because its gravity distorts the light from distant galaxies. We observe its effects, but we don't know what it is. Dark matter should also be slowing the expansion of the universe, but we've discovered that several billion years ago, a mysterious repulsive force began to accelerate that expansion. We call this strange force dark energy. Such new plot development suggests that our story of the Big Bang is incomplete. There is plenty of work for future Ptolemies, Galileos, and Hubble's. We've learned much since Ptolemy's time. The universe is not static, it is changing in mysterious ways. Earth is clearly not at the center. Even our galaxy, the Milky Way, is just one of billions. It hovers in the outskirts of the supercluster, which contains thousands of galaxies, many much larger than the Milky Way. We live toward the edge of this community, in a neighborhood populated by a number of dwarf galaxies and two big ones, the Milky Way and the Andromeda Galaxy. Sailing past the Andromeda Galaxy, it's tempting to wonder if other beings live here, contemplating the universe and pondering their place in it. Our home, the Milky Way galaxy. Spiral arms are lit up by bright stars and crossed by lanes of dust and glowing hydrogen. Out of this gas and dust, stars are born. When stars die, they return to the sea of gas and dust that fills our galaxy. Our sun and its family of planets were born from the immense strands of stardust that lace the Milky Way. Earth and everything on it is made of stardust. Of the 400 billion stars of the Milky Way, there is one that is terribly important to us. It's not very bright or big, but our sun has shone with a steady golden light for billions of years, making life possible. Why does any of this matter? Why do we care what happened billions of years ago in galaxies far, far away? Why do we care about other stars and other worlds? It's a matter of survival. Consider Mars. It once had oceans. Now it's a bitter, cold desert. How could an entire planet change so drastically? The catastrophe of one world may become a lesson for another. What we learned from Mars could guide us in protecting our own environment, just as we learn about ourselves from studying other creatures. We can learn about our planet by understanding distant worlds. "66 million years ago, an asteroid slammed into Earth and radically altered the climate. 80% of all living things, including the dinosaurs, became extinct. Just 200 years ago, we didn't even know asteroids exist. Today, we might be able to deflect one should it be headed our way and save ourselves from extinction." Understanding asteroids and climate change is certainly critical. But what about dark matter and the expansion of the universe? Right now, we can't say. But our cities blaze with light because Thomas Edison was curious about something that once seemed just as strange: electricity. We human beings have survived not because we are particularly strong or fast or fierce, but because we are curious and inventive. Earth may not be the center of the universe, but it is our center. It is the only place, as far as we know, where conscious beings ponder the universe and strive to give it meaning, to find answers to those age-old fundamental questions. Who are we? How did we get here? Why is the world the way it is? Very little in the universe changes during a human lifetime. The stars we see each night are the same ones our ancestors told stories about thousands of years ago. What does change is the depth of our knowledge, our perception of the universe, and our place in it. Like Earth and everything on it, we're made of stardust. Fascinated by the night sky. when we go to the stars. With our spacecraft, with our telescopes, and in our minds. We're going home.